So this is a brown bag I was going to do several months ago, and for one reason or another, companies being sold, me going for job interviews, etc., it never happened. Bone idleness might have played a part as well. I've had a quick look through the slides, but if I'm looking if I pause or look really confused, it's because something's come up that I don't remember writing. Yeah, so let's crack on. Git, it's just like Subversion, right? So, in the time I've been at late rooms, there's been a massive rise in popularity of Git. When I started, we were all on Subversion, and Git didn't exist. And then Git came along, and everyone suddenly switched to it, or have been switching to it. It's now more popular than Subversion, by some measurements, as of last year. And it seems to be accelerating. And yeah, why are people actually switching to it? They're doing it because it's a shame this isn't bigger. It's new, shiny, and cool. It's distributed. You can work offline. It gives you lightweight branches. It's flexible. GitHub. I've actually seen people say you should move to Git because then you have GitHub. And you can use it just like Subversion is an argument I hear people giving as well as various just fanning out over stuff. But the one I want to focus on today is the claim that you can use it just like Subversion. This is sold to people in organizations that, you're all used to using Subversion, you've grown up with Subversion, you're all comfortable using it, well, you can use Git just the same way, so there's that barrier to moving to using Git. Let's talk about Subversion. Subversion is pretty simple to understand. Who here has actually used Subversion? Is everyone familiar with it? Everyone comfortable using it? Comfortable with the idea that this is what a revision is? It's a bunch of deltas, as well as a list of the files and directories that have actually changed. That's it, that's what a revision is. It's all one single file. People comfortable with what a delta is? Just a list of changes. Okay, so delta is, it's got two files and you compare them. The delta is just what the differences are from one file to the next. So if you've got the original file and a delta, you can apply that delta to the file and get the new one. It's just a sort of transformation. So it's a way of cutting down on the size of every time Subversion just saves what the differences are in that revision. Right. And that's all that a revision is in Git, and it is one single flat file. And every time you make a new revision, it literally makes a new one of these. They're numbered in the order that they are actually done in, and that collection of files, which is there as a collection of files on your disk, is a complete history of the workspace under version control. That's actually how the current backend for Subversion works. The original one was the same, except the arrows went in the other direction. What it stored was the most current, and then the differences going back in time. But that's an aside. So I've got some points here. As it's centralized, truth is never in dispute. There is one single server which actually keeps this. Whenever you check it out, you are just getting the current revision that you're wanting. The server keeps the truth. To actually check out, you start at 0, which is the beginning of the entire revision history, the entire version history, and then they just apply deltas all the way through until you have the current set of files. Which can mean that as repositories get older and bigger, they can take longer to check out. It's not normally that much of a problem. And you can even just go and have a look at that yourself. If you've got a Subversion repository, you can go and have a look in repo routes, db rebs, and actually see all those files, and they are just flat text files. So, who's used Subversion branches? Where on earth are branches on any of this? And my laser pointer doesn't work on this TV. Yeah. There are no branches in this. So, but we can do branching in Subversion. So, how does branching work? Or when is the root of your workspace not the root of your workspace? The Second line there probably gives a bit of a clue. It's a big fudge. So, tricks with symlinks. As an optimization, Subversion uses symlinks for files that are just copies of files it already knows about. Does everyone know what a symlink is? Symbolic link? Yeah. So if you don't, it's instead of being the hard reference to a physical file, it is a soft one, really. So you can end up with the file appearing in multiple folders, but it all actually resolves down to the single file on the disk. So Subversion is smart enough to actually just make symlinks to files. If you copy it and move it around, it just has a symlink to it. And someone hit on the pleasant side effects of this. That means if you keep your entire workspace in a particular directory, say called trunk, you can simulate branching with it by having another directory called, say, branches, and every time you want to branch, you just take a copy of trunk and stick it into branches with a new name. And because of symlink, it's a pretty lightweight, it's a very lightweight operation. It doesn't add dramatically to disk space. It's still reasonably fast. So functionality has been added over the years to support this, but at its core, it still mostly works on branching by convention in Subversion. Let's talk about Git. So, Git, at its core, is a key value store. It's an object store, keyed off of the SHA-1 hash of the object. So, as it's at the core of Subversion, there is a whole bunch of flat text files of delta and changes, which makes a revision. But at the center of Git, there is an object store. Some of my notes are missing off this, so I'll have to read this one. So what are these Git objects in the stores? They can be one of four things. They are blobs, which are the files themselves, just a text file or any old binary thing. It's a binary large object, so I think that's what blob stands for. They can be trees, which are directory structures like things. I'm going to go into each of these in more depth. They can be commits, and there can be tags. Those are the four objects that make up a Git object, that can be a Git object. And they're all just stored in this key value store at the center of it all. So, blobs. Blobs are text files, or binary files. And they are stored into the key object store by hashing it to generate a unique ID. So, you're laughing at this. They're hashed and zipped and then inserted into the key value store. And you can actually get them out. You can inspect it. You can get files out by their hash ID. And interestingly, you can generate your own entries in the key object store just by generating, say, a bunch of text, hashing it, and inserting it with some of the low-level commands. So you can actually insert files that never ever existed in there directly. Trees. So trees are also pretty easy to understand. They are just kind of containers. They contain links to other trees and blobs. So they simulate directory structure. So see here a tree on the left. It's got two blobs indexed by their hash IDs and what their file names are. A couple of trees, hash IDs once again, and what their folder names are. So between blobs and trees, you have the directory structure and the files that are actually in them. And notice like I said, tree and blob references here. They use the hash IDs of those blobs and trees. Just in here, and once again, it's all hashed and zipped and stuffed into the object store. Commits are also just a text file. A commit references a tree, and the parent of this commit, which is another commit, and has some authoring information, names, dates, emails, and the commit message. And once again, that's just then hashed, zipped, and put into the object store. And I don't think I'm going to talk about tags because that's just off to the side, but they're a bit like commits. They're a bit like commits that have a parent node. So every time you commit new and modified files, every time you commit new and modified files, anything that's changed is hashed and zipped and stored away along with new trees if needed, and a commit object is created and stored too. So every time you actually take a snapshot in Git, it actually takes a snapshot of the entire workspace as it is then. So any new files, any file you've changed, if you've got a 5 meg file and you change a single character in it, it will hash the entire thing and store the entire thing. So they like you to think in Git about snapshots rather than revisions, rather than thinking about this is a modified file system. It's like, no, this is a snapshot of the way things are now. Which has some benefits. It means you don't actually have to apply previous revisions to check out. You actually just get the latest thing. It doesn't start off at day naught and fast forward through it all.
So if you edit one character in one 5 meg file, does the snapshot include that 5 meg file and the other 100 meg?
Yes.
Of your workspace?
Yeah.
So you can change one character and that commit can generate 100 megs worth of...
Yes.
So
doesn't sound so great so far, does it?
Not so far.
I don't quite get where the revision
like
relates to the commit, so the list of deltas that you mentioned before.
That was Subversion.
Oh, so that's, sorry, I thought you said it's the same in Git. It's not the same. So this is instead of the revision.
This is instead of, so yes, Subversion, very simple. In fact, it was really quick. Just that list of revisions, and we're done with Subversion. That's all that Subversion does.
Right, okay.
I should have said at the time, actually, that Subversion is great because it's so simplistic. The power to complexity ratio makes Subversion very good, but Git's better. So yes, your point there, yes, quickly end up with lots of objects. Doesn't look so great so far.
Why does it track the parent hash? Is that not to apply deltas? That's
not to apply deltas, no. I'll get to that. So, talking of deltas, where are the deltas? Because at the moment we have a whole lot of loose objects. What Git calls loose objects, which are just these blobs, trees, commits, and tags. And they're uncompressed. Well, they're zipped, but we don't do much between. So, objects. Initially, things are stored as loose objects, but when Git decides to, it compresses them into pack files. So occasionally Git does some garbage collection. It does this when you actually do a Git push. I think it does it when you do a Git pull. And it'll do it every now and again if it just thinks that the number of loose objects on your disk is getting a bit excessive or a bit large. Yep. So it'll actually go through and compress all of this into a pack file and an index. And this is where deltas start happening. Because what it will do when it comes to compress all of these is it will compare all these files against each other to find which ones are similar. It will take your current ones, what you've got out currently as kind of like the base, and then start working out efficient ways of generating all the other ones out of them. So it will start doing that diffing and deltafying of files, but only when it does garbage collection. But an interesting point to note here is that those diffs are not necessarily between different revisions of the same file. It will actually check all the files. There is actually a parameter to say how exhaustively it should hunt through the object space for similar looking files, and it'll actually compress things really well because they'll be. So that one I said of you've got a really large file, you change one character. Well, at this point now, it would do the deltas. But interestingly, if you'd had two completely separate files, which now had through completely, it's a slightly tortuous example, become almost identical bar one character, it would make one be a diff of the other, even though they were never originally related in any way. So this is what it does, this is where it does use deltas, and this actually generates much smaller compressed repos than subversions. In fact, it's really good at compression. I think I was experimenting with this a couple of months ago and I was putting this together and I pulled out a CSV of our hotel stock in the UK or something.
Yes.
It was like 30 or 40 meg. And playing around with Subversion, it quickly grew to, I think, nearly a gig of hard disk space, with a lot of copying, pasting, renaming, moving, etc. Whereas the Git repo, once it had done a compression, actually was down to about 7 meg. All the way through. Also, I forgot to mention that while Git occasionally does the garbage collection, like when you push, pull, when it decides that it needs to do so, Subversion, you have to manually do the cleanup, otherwise it will keep hold of old things which don't exist anymore indefinitely, which is how I ended up with a gig of hard disk space being used up by a Subversion repo which had one file in it. One 40 meg file in it. So the important thing is it will take all of these, it'll stick them into one big flat file with an index, so all the deltas, everything, and it'll use that like a flat file database type thing, and start making new loose objects as they're needed. So visualizing commits as a graph. Let's go back a little bit here. So there's a question about the parents. So that ID there is the ID of another commit. And commits can have 0, 1, or 2 parents. So your initial commit has no parents, because it's the first one. Normal commits have a single parent. But a merge has 2 parents. Now, by looking at a commit and then examining its parents and its parents and its parents and so on, you can actually then start building up a tree of the gits. So this is visualizing it as a graph based on what parents a commit has. And you can start seeing that, yes, these 2 commits here both have this single parent, so the graph bifurcates. Oh yes, the graph is, if anyone's into their graph theory, this is a directed acyclic graph, or acyclic graph, which I had to go and look up what that actually meant. It's a really fancy way of saying that the connections between nodes only go one way, and so that's directed, and acyclic, that sounds quite right, means that starting at any single node, you can't get back to that one. There's only one way through, so you can't go back along it. So it's a directed acyclic graph, and that is the most technical jargon I will throw at you the entire thing, I promise. So it's pretty far removed from Subversion now, which is just a lot of flat files. Forward again. So we've got blobs, commits, we've got blobs, trees, commits, tags I'm not talking about. We can take commits, look at their parents, to draw it out as a nice graph, which leaves us with the final piece of the puzzle, which is how branches and head and things like that work in this. So it's all well and good that we can we can take this theoretical object-based database and turn it into a pretty graph. But day-to-day working with it, how do we navigate? So let's start with a branch. Here's a very simple node graph. A branch is just a reference to a commit hash. That's all it is in Subversion. So in Git. If you remember, in Subversion, a graph was actually a symbolically linked copy of the entire root of your workspace. In Git, I'm going to get them the wrong way around all the way through. It is literally, in fact, you can go and have a look in your Git repo as well. Refs, heads, master, refs, heads, another branch. It is a text file with one single line in it, which is just what commit that branch points at. Next. Head. Okay, so yes, branches, that's nice. And then head is also, head is generally a reference to a reference to a branch. And head is just which branch you're actually on at the moment. So ultimately, that usually resolves down to a single hash as well. Well, it will always revolve to a single hash. Normally, it's a reference to a branch. If somehow, magically, or not so magically, you go off the reservation and your head points directly at a commit hash.
Detached head.
Yep. Or more specifically, points directly at a hash reference which isn't behind or isn't reachable from any of your branch references, then it's a detached head. No, you're right. Yeah, if it's pointing directly at a hash, it's a detached head, which means it's not currently in any of the branches. Git likes to keep track of where the tips of all these branches are. And if you end up on one which isn't on it, then you're on a detached head, which causes everyone to delete their repository and check it out again and start their work all over again. But you shouldn't have to. What do people actually do when they get a detached head? Yeah.
Let's go back to a branch again. I mean, I quite often get a detached head on purpose because I just want to check out a particular commit and look at it.
Mm-hmm.
I just make sure that I go back to a branch again when I'm done.
If you
check out the branch, don't you?
Yep.
And then you are back onto that branch, or your code is still there.
So if you've ended up with a commit off to the side somewhere, you're pointing at a hash, it's not on a branch. Easy thing to do is actually just create a new branch, because it will just drop a branch pointer right where you are, and now you're no longer on a detached head. The other one you can end up with is if your head ends up on a commit ahead of the branch tip, and that's called a dangling commit. No, forget that. I'm trying to explain too much on this one slide. So when you create a, unfortunately I made this really big for myself. So yes, when you create a new branch, it just looks at what your head is currently pointing at, what hash it's currently pointing at, and then makes a brand new branch with that commit hash. So if branching was light in Subversion with its symlinks, this is ridiculously light because it's one line of text in a text file. What else have we got? Oh yeah, so that's making a brand new branch there. So if we're currently on a feature here, and our head is there, if I make a new branch, it literally makes that one file, and it's got the same commit hash as that. So, in summary, Subversion looks like that, and Git looks like that. And that's a pretty high-level overview of the differences between Subversion and Git. Which is all I really wanted to cover today. I didn't want to get down into actual commands right now. Questions? This is probably where this will probably go on for a bit longer.
You mentioned your people are able to insert files directly into the original batch. Does that not pose a security risk?
Well, if they've got the ability to put them in already, then they could just as easily put the actual files in. But it does open up the possibility for being able to do things like having Git backing other things like, say, a wiki or something. Because it means that effectively you can deal with a file store that doesn't actually have to be a physical file store. So yes, you can stick anything in, but when it does the garbage collection, I didn't mention what it will actually do is it will go and find any files. It will work back from all the branches, through all the commits, checking all the files, all the blobs, all the trees. And if there are ones it can't reach, it will delete them. So if you just insert random stuff into there as part of the garbage collection, it will get deleted, ultimately. It's not really a security risk, because it's pretty much the same level of ability. You have to just put in the file in. It's just an interesting thing you can do with it. So.
I'm trying to formulate a question to do with when you get stuck.
I should probably say here, yeah. So let's use this as an example here. So, I think lots of the power from Git comes around realize when you kind of get that it's a big tree, and that's what your commands when you're checking out or resetting or whatever. What you're really doing is just navigating around this tree. So when you've got a head, which is just your reference to where you are at the moment. So you're on a feature. If you go check out master, it will obviously go and retrieve the files, change over what's there, and it will point your head now at master. You've moved your head, which is your where you are around. If you reset back to an earlier revision once again, say if I'm here head on a feature and I go whoops, I'm working locally, I shouldn't have done that. I can do a git reset head -1 tilde1, and I can just point my head back up a step. It can really do with. And this was what I wanted to follow this up with. Was a bit more of a practical demonstration of actually then navigating around and stuff. But I decided to leave the company instead. After that, I'm leaving.
Are you able to describe the process of what happens when you do a merge under the hood?
Right, so if we're here, if we're let's which one would be better?
That's better.
Yeah, go for this bit here. So pretty standard workflow. We've got let's say this is master along the center here, and at this point here, someone has done a branch off of master and done some work. In the meantime, someone's done some work. Something's ended up on master. So at this point here, this is a merge happening. So Git doesn't bother keeping changes, doesn't bother tracking revisions between snapshots, doesn't bother tracking the changes in files between snapshots. Git relies on the idea that there are much better tools for just comparing differences. So when you do a merge from master into this branch, Git will go, okay, this is what this snapshot looks like, this is what that snapshot looks like. Can I do a clean diff of these two files, workspaces, whatever? And if I can, excellent. Let's apply that diff apply the diff and stick it on here. And then make, a new commit here which has both of these cited as parents. It will, just try, no. it will go difference between here and here. This is a common point where they separated. Difference between these two here, take that diff and apply it to this snapshot here. Can I do it cleanly? Excellent. Then that's a merge. It's, yeah. So in the future, if we got to this one here and did a merge in from master again, it would go back in master to the last time that one of its nodes had a common parent, which is this one here. If that hadn't happened, if that merge there hadn't happened, it would go, right, so this branch here, where does it end up with a node that's also a master? Right, from that one to the head of master, make a big diff and try and apply it.
And what happens if there's a
rebase?
conflict? Oh, sorry.
Well,
Either rebase or conflict. What happens when there's a conflict?
When there's a conflict, it is just generally that it can't make a clean. The diff from here to here, there is some overlap with something which has changed here.
But what does it actually do? Because you start seeing these files that have got.
Well, it forces you to make a decision. It forces you to make a new version of that. So,
But it does actually create new files with the chevron,
Yeah,
doesn't it? It
it'll,
does actually do something.
So that is that's the sort of Linux merge conflict file thing where it's going through and it's putting the file in question, but every time there's an area of overlap, it will show you both sections. So it'll have the chevron for the first bit, and then a load of equal signs for the line across the middle, and then chevron for the second bit, and you can see, okay, up to this point, the file's fine, but at this point, it's either this or this.
So that's the bit I always struggle to read. It's not intuitive to me. That there's some chevrons, and I'm not quite sure what they're telling me.
You can get some programs which will display it in a more human-readable fashion. Beyond Compare, I think, is my favourite.
yeah,
KDIV 3 is also good as a free one.
Brilliant.
Yeah,
Yeah,
I
yeah.
use KDIV 3. Yeah, but
Because
and
KDIV
just
3 will show
ignore the
here's
chevrons, 'cause the chevrons are
file
not
1, here's
helpful.
file 2. I've highlighted the conflicting pieces,
yeah.
and then you can decide to pick and mix them. Rebasing. Okay. So rebasing is actually kind of simple. Because rebasing is saying, right, a feature points at this commit hash here, whereas actually I want it to point at another one. So if you do a git rebase, it literally just replaces one hash with another. You just go, well, I know the history says that, I know the branch says that it points at this commit hash, but actually it should, this is all a big mistake, it should never have happened, so let's rebase to here. So a feature will now actually point at this commit hash, and that commit is still there, but it's now an orphaned, it's a dangling commit, which means it will be picked up by the garbage collector and just binned. The complexity in rebase comes from how do you, or the bit which tricks people up is probably how do you deal with the changes in the files, like do you want to keep them, do you want to get rid of them, do you just want to, how do you want it, because there's hard and soft and whatever the one in the middle is.
So like, when I've come across it, it's like, oh, it'll actually be better to do a rebase for this, because then the commit history looks better. But then it goes through the commands and it ends up having to go to the command line too, because I end up with it saying that I'm 3 ahead and 4 behind, and it's how can I be ahead and behind? It's alright, it just does it.
So that sounds like, that's...
So I always ask for help when I'm doing it, and it seems straightforward, but
It's
I don't understand what
straightforward,
it's actually
as long as you haven't pushed up to a remote repository. There's something I haven't touched on in this at all is remote branches. So say you're on your machine here, you've got develop and you've got master, and up on the repository you've got develop and you've got master. Now Git is distributed, which means that neither of your repositories, the one on your machine or the one on GitLab or GitHub, are actually magical. There is no such thing as the server-side repository, but it still has to somehow have this idea of that those branches up on the repository mean something, up on GitLab mean something. So it has remote branches in your local one. So there are a couple of branches you don't directly actually work with. So you have develop and master, but you also have remote develop and remote master, which it tries really hard to keep as to keep in line with what's happening on this other repository, this other up in GitLab or GitHub. So when it complains that you are 3 ahead, 3 behind, 3 to the side, whatever, it's really saying that, right, you've said that your local branches are like this, but there's a mismatch between what you've got and what the remote one has the last time I looked. And I'm not sure 100%, well, there's no clean way of resolving that. So it sounds like what's happened there, you've done a rebase, but the changes have already been pushed up to the remote. So you say rebased master from here back to
working
here.
on a feature branch. That feature branch has been pushed, so it's on the remote.
Mm-hmm.
But then there's other things going on the develop branch, and rather than trying to merge the feature into the develop branch, it's we've only changed one file or whatever. So it'd be better if that in the history appeared as a commit on the current head of develop.
Right.
So we'll rebase the feature.
I've just realised I've been talking about reset.
Yeah, I was thinking.
Rebase, okay. So, rebase. What happens when you rebase? So we've got a feature here, and in your case, yes, you're talking about rebasing onto the new tip of master.
Or develop, or whatever.
Or whatever.
I've got a feature
Develop,
branch
yeah,
that I've
develop.
branched off develop.
Mhm.
I've done some work on that. Meanwhile, other people have been doing work on their own feature branches. They've been merged or whatever back into develop. So the source of my feature branch is quite far behind develop
Yes,
now.
right.
And rather than trying to, it seemed like it was preferable to rebase rather than merge. I don't know whether that is a convention or whether
It's a point of contention. I like it, but people who are against it do cite that it's basically a lot of people going, "Oh, it makes my graph look pretty." There is an element of truth in that. So when you rebase, for this example, we've got a feature which has been taken off of this master branch here, but something's been committed to master and wanting to move the feature. So what happens when you rebase is it makes a new branch kind of off of, say, master, and then it goes through applying the changes from a feature here, between here, it'll apply that to the new one that's been taken off of master. So it kind of replays your work. The diff between here and here replayed on top of that, and it'll do that for each one, and then it will set that as your new branch, and it'll remove. So this is still actually here. You've rebased, but your old branch is actually still there. It's just now a dangling commit, because it's just taken all of the changes, diff, and replayed them on top of whatever one you've just rebased it on.
So it's just resetting the parent, is it?
No. It looks like it does, but if you go and inspect your commit hashes on all of these, they are new ones because they're actually new. Your old branch is still there. You can actually get at it. If you can remember the hashes, you can find it, you can get to it, you can check out a new branch on it so it doesn't get deleted and everything. But what it's really done is made a brand new set of commits with new commit hashes and everything just on top of this one. It's kind of like, packaging up everything that's done, everything I did, now do it again as if I'd taken it off of this branch. You can go through and kind of simulate this doing the git cherry pick commands, which I can't do here. But it shows you kind of a long-winded step-by-step. I'm like, okay, making a branch, a feature one, cherry pick changes from here to here, stick them onto a feature one, and then reset a feature to now point at where a feature 1 is, and then delete a feature 1, and that's kind of a really long-winded way of doing a rebase using cherry pick. It looks like it moves your branch. It actually makes a brand new one, just replaying what you've done as if you've done it from that point. And yeah, it makes a nice clean commit history.
And do your old commits stay there indefinitely, or do they get garbage collected?
Because they now no longer are reachable from a branch tip, they are eligible to be garbage collected. So yes, they will disappear the next time you have a garbage collection. How are we doing for time? Oh. About 10 minutes left.
How long does it keep the orphan branches hanging? Because I managed to get the stuff in the right picker before, but I was able to just go back to the orphaned.
If you've pushed, they're gone. Mainly what causes the garbage collection is having done a push, because it will go and do the compression, and as part of the compression it will get rid of unwanted objects.
So will it get rid of it locally and remotely?
Remotely, I don't know how often it remotely cleans them up.
Because I think I managed to recover from. Actually, I think I managed to recover from the remote.
Yeah, I don't know. I think then it's kind of an implementation detail about when Git decides to do a cleanup. Because if you do a push, it cleans up your local one. If it's push 2, I don't know if that triggers a garbage collection or a pull. But it's kind of an implementation detail for how long it can keep them. There might even be some config you can fiddle with to say. I mean, certainly for doing the bit about deltafying everything, there is actually some config that you can choose to say how exhaustive Git should go and search for like files. So if you really want your Git commits to, or your Git pushes to take several minutes, you can actually whack it right up and have a very small local commit that takes forever. But yeah, I wouldn't rely on it keeping the orphan files, but it's worth knowing they're there if something goes horribly wrong.
Yeah, because it did go horribly wrong for me. I pushed to
that is an important thing to actually. That is one of the important things to know about when working with Git is when everything goes horrendously wrong, don't panic because everything is still there.
Yeah, what I found was that it's gone horrendously wrong for someone on the internet already, so there will be a blog about it and they will tell you how to recover.
It all looks terrible when files disappear or disappear into merge conflicts, so you get really bizarre error messages, but you got to remember you are navigating a tree structure and you're just pointing at the wrong bit. All you got to do is work out how to get it back to pointing to where you want to be.
And if you want to really get to know what's going on, it's worth learning your way around the Git folder, isn't it? You know, you get a .git folder in every repository, and there's a lot of useful stuff in there.
Well, it has all of the heads, where your current head is, all the hashed and zipped up objects are there, your pack files there. It's worth having a look at. Just don't go and... You can actually make one of these text files yourself and it'll suddenly magically be a branch locally.
Yes.
So sort of moments.
What about the difference between reset and revert?
So reset is reset is a bit of a sledgehammer. It is just kind of like, I want to move back up the chain somewhere and I want to do it hard, which means any changes in files, just bin them, or they're soft, which is, well, alright, just keep them, but have all the changes that would change, but have them staged. So I've got that one, and then I can go through and decide whether or not to keep those changes that I made and whatnot. Whereas Git reverse, I think, is really just undoing what you've done.
I think it creates new commits, doesn't it?
I don't use it very often. Does it make a new... Gary, you're big on Git. You know, Git revert makes new commits.
It does.
It does, yeah. Is
Yeah, it undoes a particular commit and then does a new commit, which corresponds to the change involved in undoing the previous
Alright.
commit.
And then
So
if
it
you
means
revert
it's
that
traceable.
one, it's another commit. That
Yeah.
reverted that.
So it's
Reverted
ah,
that.
It
so
means
Git
nothing,
revert works.
nothing gets lost, basically.
It works very similarly to then how reverts are done in Subversion. So obviously in Subversion, yes, because it's a diff. When you undo it, reverse it, it just does the anti-diff, as it were. Does the diff the other way around, and I guess Git revert does the same way.
Because they're similar words, I often
Yeah.
forget which one is the safe one.
I
Revert
would-
is the safer one. Reset is the scarier one.
Yeah, some of the wording they've chosen in Git is not fantastic. Also, the fact that sometimes they refer to the same thing with different names in different places is another one. Like, is it staged or is it cached? Yeah. You stage the changes, but then if you do a diff, you're doing it against the cached versions, which are the staged versions, which are the cached versions.
Does everybody know the git stash command?
Sounds basketball.
Because that's really useful.
Where we use Git stash.
Git stash, yeah. You can use it multiple times, can't you?
Yeah, you can.
More
You can. It will create.
changes.
You can name them as well, so you can just keep repeatedly stashing, and it will unstage. I think it does it unstaged. It unstages whatever you've got staged, and just sticks it in a file, I guess, so that it's available. You can then apply it to any other branch. So if you're in when I most often use it is if I'm in the wrong branch, I've forgotten to create a new branch for a feature, and I've started working in develop. And then I realise my mistake, so I do a stash, create a new branch, and then apply the stash, and it will be put into my new branch and taken off wherever I was before.
I think internally it stores stash things. I haven't checked this, but I think it stores them as refs. A bit like, so it stores them in the same way that it does branches.
They have
IDs.
IDs.
So, yeah.
Yeah, they have
Because
IDs.
if you've got it stashed, it will actually kind of do a commit. So, and then yes, it's kind of like a special. It's not even a special commit. It's just the way that you reference it. Then is kind of a special.
And then you can name them if you want, but you don't have to.
Mhm.
Give it a descriptive string, and then if you do get stash list, it will show you all your stashes, so you can find the one you want and apply that one.
Yeah. So actually, yes, the way stashing works, it must be in the references again. A bit like heads for the heads of the branches. You've got stashes just pointing at particular commits. So it actually does store them away in the object store.
I've got notes on it if you want them. I'll email them to you. I'll make notes on it.
How the Git achieve the distributed repository? It's not disconnected, but not related, no common. Then you can merge then.
Yeah, it's because it's because when you do clone a remote or set another repository as to be a remote, you don't have to clone the repository to actually set it as a remote. You make kind of shadow branches on your machine. This is you've got master, but then you've got remote master. So you don't directly update remote master. When you say git pull, it looks at the remote, it works out what commits it needs to pull. There's actually more time in this explanation than I have left for how it does it. Basically, when you do a pull of a branch, it will look at your local remote. So let's say we've got remote master. It'll go, right, remote master is at this commit hash. Then it will go off to the remote repository and go, right, this commit hash. What do I have? Well, yeah, I've got this commit hash. What can you give me? So the remote repository at that point will find a branch which has that on its parent. Well, so we're on master. It'll go, master, this commit hash. Okay, so I know where master is, and this is this commit hash, which means that these commits have happened since, which means that I have these trees and these blobs, right, stick them all into a pack file and give them to you. You'll get it back, it'll open up the pack file, it'll add them into your object store, and it will reset master to point at the new highest commit that it's just sent. So it basically sends you a bunch of objects which are the commits and the blobs and the trees that you need to bring it in line. It'll then point your remote master branch at that head, And when it's done all of that, it'll then go to your working master one and try and fast forward your working master to the same point. This is where you can end up with the your local one is 3 commits behind and 2 to the front, 2 in front of this, which is where you've ended up going off somehow. It's usually someone's rewritten history on the server and needs to be punched when that happens. Have you asked Joe?
It happens when I do a rebase.
Yeah. It can happen when you're pulling from remote branches as well if someone has rewritten history. Yeah. So what it will do is it will try, yes, to pull down the master, get the commits, update its local copy of remote master, which should match and should go cleanly. If it doesn't, things have gone horrible. And then it will try to update your local master in line with that one.
This is one of the reasons that resets are dangerous, because if you push, then you can bugger everything
Reset
else up.
is completely fine as long as it's local and your changes haven't been pushed. Similarly with rebasing, I think, maybe. Should be fine. Yeah, should be fine as long as it's local to you and no one else is going to be hurt by you doing these things. If you rewrite history that's already been published to a remote server, then someone somewhere is probably going to have a bad time. In fact, if you have already rewritten history to something that's already been pushed up, when you try and push it up, it will complain loudly about it and tell you can't do it unless you force it. If you get that, you really should think about what it is you're doing. It might be the right thing, but it's like all these warnings, it's there for a reason. But if you're working locally, feel free to rewrite history. It's great. It's great. You can make loads of commits. You can realize that it's all wrong. You can reverse or reset all the way back. Yeah. You can also, if you've done a local commit and then realize that actually you haven't saved that one file, you can amend your last commit and just add what changes you've got now into the previous commits. Once again, it's rewriting history. All good. Any other questions? I think we're kind of out of time. Yeah.
Thank you very much.
Thank you.
Thank you.